And all right, so it's recording. It's going to be 3 videos. One is just WEKA, and then 2 of XGBoost, because I'll do 2 data sets, right? And that's kind of it, so you guys get a feel for it. So the point with these lectures is that deep learning, PyTorch is like, I don't know, like a B-2 bomber or something, stealth, right? You don't always need something like that. Sometimes a drone will do it, right? A paper drone or something will do it. And so, not that XGBoost is, a paper drone. I don't want to say that. It's a pretty advanced thing, but it's not neural networks. It's just a simple thing. And, or something called regression trees are not deep learning. And yet, they may be still a good tool and may be able to beat deep learning algorithms. Does that make sense? Or at least it's harder to get a deep learning algorithm to actually train correctly and get all the parameters, et cetera, and the regression trees, et cetera, might do a better job. So that's kind of what we're seeing, right? So if you notice, what are we tackling? We're tackling the wine data set. Yes, that's the homework, right? It's the wine data set. What are you trying to predict? Wine quality, right? And we have, I think, like 11 inputs. Okay, so we've been using PyTorch to build neural networks. We did a linear regression, multi-layer perceptron, deep learning, F1 plus F2, and we're somewhere around 40. We didn't quite get to 40, right? So now what we're going to do is we're going to look at other techniques, right? And so my go-to whenever I just want to try what I would call like more of the traditional machine learning algorithms is to go to WEKA. So I don't know if you guys have used WEKA before, but it's a very nice tool. You can get it online for free. It's just WEKA, right? So you can go there and download it and go ahead if you want. It should take only a few minutes to download. I'll give you a couple minutes to download and then, follow along, basically. Make sense? Yeah. So let me open it because I already have it here. So that's WEKA 3.86. I believe there's a second version that now supports deep learning and things like that. I'm just using the more traditional one. This is what I've been using for 15 years or so, and I really like it still, right? So it tells you something about how a lot of things changed, come in, and yet I still like this thing. All right, and so I still go to it, and it's real. Like I said, I like it as quick prototyping just to get a feel for my data really quickly. This was done really well at the University of Waikato in Hamilton, New Zealand. All right, and they still support it to this day. All right, so there's a lot of features in WEKA. We are not going to explore all the features. That's not the goal. Instead, I'm just going for the regression problem, okay? Later on in the semester, if we have other problems where it makes sense to come back, I'll show you how to tackle those, but we're looking at things from a problem point of view, okay? So is everyone caught up? Did you all download it? Any questions? I can see some of you are downloading. Go through the windows, and then just raise your hand when you think you have it. And all the, like I said, the videos are already posted. So try to get to this bird. All right, so I can see some of you already have it. Good. So we're going to get started then. Basically, like I said, there's a lot of features for this, and it's powerful. Now, it supports fairly large data sets. So this will support maybe a data set that is, I would say, 100,000 rows by 10,000 columns. That's about as big a matrix as it can handle. There's a feature in WEKA, and one of the jar files that allows you to increase the RAM. So I think by default, the RAM is like 1 gig. And if you have a machine that has 8 or 16, you can, bump it up. And that's important for doing certain things, okay? All right, so certain algorithms will require more memory than others. So just be aware of that. We are not going to be using it in this manner. Our data sets are small, but just be aware. Now, if you had a really big data problem and you still wanted to run WEKA, what I would suggest is just take randomly a subsample of that data set and run it on WEKA. If you, let's say you had 2 million records, right, which might not fit. One good idea would be to randomly select 100,000 of those. That's a good representation of the 2 million. And then you can load it on WEKA, run all the analytics on WEKA, and you'll have a nice picture of what's going on. You know what I mean? So it just so happens that the type of problem we are tackling right now, neural networks may not be the best solution. Why? Because we're tackling tabular data. Tabular data is this kind of regression type data where we have like 11 inputs, a small data set, one output, which is regression output, right? So what is deep learning good for nowadays? It's good for leveraging the advanced algorithms that it has, like CNNs and transformers and autoencoders and those kinds of things. So if you have a natural language processing problem, or you have an image analysis type of a thing, then that's what deep learning is good for. And there's a lot of power there. But our data sets are pretty simple, right? Now, I'm not saying that deep learning can't solve it. As you can see, we're almost at 40, right? But I'm going to show you some other techniques that are available. Okay. Any questions? All right, so let's go ahead. So this is kind of like just showing you how to use it. So it's pretty easy. You click on Explore, then it'll open this window here. Sorry. So it opens this window. Not sure why this thing is. Thing's not going. Oh, there it goes. All right. So now what you have to do is you want to open the file. All right. So the file that we're going to be using is the wine quality file, right? So we just have to remember where we have it. I think it's in the desktop. So you can just click on Open File, and then we can navigate to the desktop. And you guys are section 1. And I think, well, you have to select specifically the data type. WEKA likes it that you select the data type. So I remember the wine quality file is a .csv file. So make sure you do this. Otherwise, it won't load. And then it's not here, so it's probably in data. So then I'm going to click on data, and I can see wine quality right there. So I'm going to click on it, and it should load. Oh, yes, of course. It's got the issue that we had also in pandas, right? That it expected a comma, and we have a semicolon. So we can just say use converter here. Yeah. So click on use converter. And then I think here it says field separator. So change that comma to a semicolon. Okay. And that should do it. So click OK. And that's it. Now, the key thing with now WEKA allows you to like take a look at all the variables. You can see here it's giving you summarizations of minimums, maximums, means, and standard deviations, a histogram of all the variables that you have in there. You see that? And this is, you know, nice analytics, right? You can start getting a feel for your data. And this is why I like WEKA, because it quickly, for some data type is very useful to start looking at little details. All right, so now what I would recommend is to take a look at the data type of the variable. So if you notice, the data type is numeric. And that's what you want for all the variables in this type of problem, which is a regression problem. Okay, so if you take a look, our target variable is number 12, quality. So that's numeric. This is numeric, 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 and so on. They're all numeric, right? So I've already checked. I know they are all numeric, but you want to double check. All right, so basically our data is ready to go. So now we can go ahead and try the different regression models, okay? So to do that, you go to classify here, and your regression models available in WEKA will also be here. So you can click on this, and now we can select. Now notice down here, there's the tenfold cross-validation. So what we've been doing in Python is we've been doing an 80% split, right? But because you're changing the seed every time you run it, you're doing a little bit of cross-validation every time the data set is different. So this is cross-validation here. This one is like a better experiment because you're repeating the experiment 10 times, randomizing the data every one of those 10 times, and using different training and test sets every time. All right, so cross-validation of 10, and then we're going to pick a few algorithms that are used for regression. If you notice, because our data is for regression, not all algorithms are selected. Some of the classification algorithms are not available here. So one thing you want to double check is that you have selected the correct target variable. So the correct target variable should be quality. And you can see that there, right? And it does say numeric, and that's what you're going to be predicting. Very important because, you know, WEKA could assume some other variable and then, you know, you'd be getting wrong results. Make sense? All right, so that's it. That's, you know, pretty easy, right? We're just going to use default parameters, and usually the default parameters are pretty good, although they can be changed. So to select the algorithms, you just go here to choose, and then we can look. I'm going to close these, right? And usually the regression models are going to, we're going to go through these, right? So Bayes has no regression models that we can use. None of them are highlighted. Functions has several. One of them, if you notice, is the multi-layer perceptron. So this is equivalent to the one we implemented in PyTorch, okay? We also have in here SMO reg. This is a support vector machines for regression called support vector regression. So that's another very powerful tool that used to be very popular before the advent of deep learning. We have simple linear regression. So these four functions you can try, okay? All right, so these are four that we can try. In the lazy ones, we could try these, although I'm not going to use any of these, but you guys can play with them if you want. I'm not going to do any of the meta ones, but there's a few available. And then I'm not going to do the rules ones, but I will do the trees. All right, so in the trees, if you notice, there's basically like these four, MSP, random tree, and so on. In particular, pay attention to the random forest. Okay, I'm going to do that one last. Okay, just to kind of you know, lead up to it. But let's basically, all we're going to do now is run all our models, and this should give us a metric that we can compare to the metric in PyTorch that we did before. Now, is it apples to apples? Not necessarily, because here we're doing tenfold cross-validation, and over there we did maybe like you run it 3 times, so 3 times it was random. So it's not quite, right? But it gives you at least a picture of what the R-square is starting to look. And WEKA here, what we're trying to do is almost like establish an interval of what is the lowest that the R-square is going to be and what is the highest the R-square is going to be. Do you see that? And hopefully this gives us insight into, okay, we could achieve this R-square. So maybe our neural nets should be this way or that way, or just go with a regression tree. I have seen papers where people implement neural nets and something called XGBoost, and they're happy with XGBoost, right? I've seen XGBoost win at a lot of competitions, right, for this type of data. People come in with neural nets, with deep learning, etc., but you don't need that, right? So a regression tree may be more appropriate for regression type tabular data that is small and has, you know, few features and not many samples. For more elaborate things like images, text, understanding, all that, generative models, deep learning. You see that? All right. Anyway, so let's start with, let's minimize this one, and let's begin with functions. And I'm going to do, you know, linear regression, kind of makes sense. Quality is, so then notice here, you just have to click the button, start. Let it think, and it's already done. Now, it gives you the correlation coefficient, which is this value here, 0.52. Correlation coefficient is known as R, and we were calculating R square, right? So just square it. So in this case, this would be, I'm just using my phone here, 0.52 times 0.52. So 0.27. Not good, right? It does not beat what we achieved already with our PyTorch, because PyTorch already had like 39 or something. Huh? 39. 39, right? So somebody achieved 39 on our PyTorch. But as I said, all we're doing, notice how quickly I'm doing this, right? So it makes sense to kind of try it out. So the next step, and this was just linear regression, so I'm going to try the multi-layer perceptron. This is like the one we did in PyTorch. Notice that the little bird there takes a little bit longer because it is a neural net. And then let's just wait to see the value. Any questions, guys? Making sense? Again, I'm just giving you tools for the competition, right? And so hopefully you guys will use all of this to achieve the highest possible score. All right, so we got a 0.52. That's 0.27, right? Yeah, 0.27. So we're kind of stuck there. Okay. Let's try another one. Let's try simple linear regression. 0.43. This one's going to be even lower, right? This is 18 R square, so not very good. Let's try another one. This is support vector regression. Support vector regression is a very interesting algorithm. Okay, and like I said, it would have been the kind of thing that you would have studied a lot before deep learning, but it's just been replaced. It's one of those things that happens, right? But it's still available, and you might find some usability for it. So and this is the WEKA implementation of it, by the way. There may be better implementations of it. So let's run SVR. Still thinking. All right. As you can see, this one takes a little bit longer. Did it finish for anyone? Or how much? 0.52. So that's 27 R squared, right? So not making much progress with these. These are basically, heavy, multi-layer perceptrons, support vector regression. So they're definitely powerful techniques that you would expect in other applications to be very good, right? But in tabular data for regression, there may not be as effective. It shouldn't take much longer, I don't think. All right, so it's on fold 7. So it should have 3 more, 8. It's doing the 10 iterations, and this is what I was telling you. So what's good about this is it's actually doing this 10 times, randomizing the data 10 times, splitting train tests. So it's not 1 R square or 1 R, but 10 averaged out. And so it's a good, more reliable, gives you a better picture of what's going on really quickly. All right, so it should be done soon. All right, there it is. And 52, as someone said, so not very good. Okay, let's go to our algorithms. That's all of our functions. So now let's, I think we're skipping Lacy. We're skipping meta. You can play with those on your own for the competition. Maybe you'll find one, right? Secret one. All right, so now let's take a look at trees, right? So let's just try M5P. It's one of the trees. .58, so slightly better, I think, right? 0.58 is 33, right? So now we made some progress already with regression, okay? But we had achieved 39 before, right? So let's now try the, we're gonna go to choose and let's try a random forest. Let's let it run. Doing the 10 folds. .74, right? So if I square that, that's better than what we had before. We were at 39. This would equivalently be 54, 0.54 r squared. So see, you get excited now because, you know, if you're in a competition, you're in good shape, right? You know, you're doing this. Now you're gonna go in and beat other people. So that's a 0.54 r squared, which is good. So this now, WEKA tells me that regression trees seem to do a good job on this type of data, which is not surprising because, again, when you have tabular data, regression, like this type of data, regression models, regression trees have been shown to be good techniques to use. Does that make sense? All right, and they're easy to use. So anyway, so we've established that our score seems to be, our R square, possibly from 0.27 to 0.54. And this was based on doing something on tenfold cross-validation. So it's a good, reliable metric, right? That we can say, okay, we can achieve 0.54. So I would expect all of you to be able to achieve 0.54 with your models. Does that make sense? Or obviously, at the end of the day, if somebody gets 0.57 and that's the highest, they win, right? And so that's your objective, is to win, right? Now, we would want 0.90, right? Obviously, but how do we do it? So I don't know. So that's the challenge, right? So that's where machine learning comes in. That's where people then define new algorithms, etc., and then they win competitions. All right, so good. So that's it as far as regression with WEKA. So the idea with this section or module was to show you this tool for regression, try a few algorithms, and prove that regression trees can be a good technique for this type of data. Any questions? Make sense? All right, great. So we're gonna, I'll pause this video now, and we're gonna move on to the next technique. So I'm gonna go